Welcome to our first video lectures. In the classroom, we study Stack and we study the Stack array implementation. That was our first lecture for the semester. In this lecture, which will be our second lecture, we are going to study the queue. We will go through queues and array implementation. If we quite remember, in the Stack implementation, we said it's last in, first out data structure, which means the last element that goes into the stack will be the first element to come out. And we did the array implementation. Today we will go through the queue. In queue is first in, first out. So queue is almost the same as a real world example. Let's say if we go to the bank or supermarket, I will join the queue from the rear or from the back, and I will come out of the queue from the front. So that means in queue data structure, we have different entrance and also different exits. We go inside the queue through the back and we come out of the queue from the front. In stack, we go inside the stack from the top and we come out also from the top. So that's the difference. So in this lecture, we will go through what is a queue and how to process a queue. Example will be the queue operations. We can insert an item into a queue, we can remove an item. This is an array implementation. So we also have to check whether the array have a storage or is full before we insert an item. Or we also check if it's empty before we remove an item. So if the queue is empty, we cannot remove an item. So that's the definition again, data structure in which the elements are added at one end called the rear and also deleted from the other end called the front. So again, queue is first in, first out. I will go through the rear and I will come out from the front. As in stack, the same thing, the middle element of the queue are inaccessible. We cannot access the middle element of the queue. In stack, we always access the element at the top of the stack. In queue, we can access an element either at the rear of the queue or in the front of the queue, but we cannot access the middle. So an example here, as we said, can be checking out line at a grocery store or in a banking. In a bank or a grocery store, I will join the line from the back and I will come out from the front. Another example is the cars at a stop line. The car in front will go first before the car that follows when the light turns to green. So this is the diagram. We have a queue here. So this is our front to my right, and the left is our back. So when I want to join the queue, I will join through the back, and when we want to come out, we come out from the front. So these are the queue operations. Again, remember, this is an array implementation. Again, array implementation. We can initialize our queue, which means if I use the queue for a couple of items and maybe there's an item inside and I want to use it again, I can delete all the items in the queue, which is to initialize the queue to an empty state. And when I want to remove an item from the queue, it's better to check for its empty queue. I will check if the queue is empty. So we call the method is empty queue. The same thing if I want to insert an item into a queue, I will check if the queue is already full, or because this is an array implementation. In linked list implementation, we do not need to check if there's a memory space or or the queue is full. Then we need a variable, or we need a method that will return the element in the front. It's more or less like the pick in a stack. Pick method, we call it to check an element on top of the stack, but we are not going to remove it. The same thing applies to the front method. The front method, we are going to check an element in front of the queue, but we are not going to remove it. Then the same thing applies to the back method. We are going to check the element at the back of the queue, but we are not going to remove it. Then add queue will be, again, our method to add an element into the queue. Delete queue will be, again, the method to delete an item from the queue. Delete means we are removing an item from the queue. So we remove from the front. And add queue, we add an element through the rear. So again, this is some textbook have a different name. So I have these two slides here to, in case we come up or you are using a different book or reading a different book. So different book if you are using a different book. So we remember NQ is the same as to add an element. And DQ is the same as removing an element. And as we said earlier, always we remove an element from the front of the queue and we insert or add an element through the back of the queue. First is the same as front. It examines the element in front of the queue. And we have is empty to check whether the queue is empty. Size also will tell us how many elements we have in the queue. And to string, this is Java. Normally, to string method automatically is called to return a string that will represent maybe in this case the queue information or elements inside. So we also have the queue exception class, since this is an array implementation. And the two things we are going to be more concerned, the two exception will be the overflow. Overflow means the queue is, there's no space. The queue is full and there's no space. When I insert an element, I'll get overflow exception. The queue is empty. There's nothing inside. So when I'm trying to remove an element from an empty queue, I will get underflow exception. Same thing applies to the stack. So overflow exception and also underflow exception. And we are going to use the runtime exception like the Java library file. So how many instance variable we need? We remember in stack we need only one instance variable, which is the top, a variable to keep track of the top element. And we created an array objects. But in queue, since we have the front and the rear, we want to keep track of what is in the front and the rear. Or anytime we input an item, we want to increment the rear because we insert an item from the rear. Anytime we remove an item, we want to increment the front since we remove an item. So in this case, we need at least two variables, queue front and queue rear, which will keep track of the first element and also to keep track of the last element. Queue rear is the last element. And the re-implementation, we have the max queue size. Again, this is a variable to specify the maximum size of the queue. This will keep track of the size of the array. So this is an example here. Let's say we have a queue and we insert a couple of items. This is our queue front, which means the first element we insert was A. We insert B, we insert C. So now the queue front index will be 0 and the queue rear will be 2, since that is the last element. Now if I want to remove an item, then A will be removed first from the front. Now there's a problem with this implementation. We can say this is a linear array implementation. So imagine we put an item, let's say we remove A, we remove B, then we put an item all the way to 99. It will look like the arrays, there's no space, but we remove two elements, so there's at least two items, two more space in the front. But with linear implementation of array, we can't do anything. So that's the problem. The only way we can solve this problem is using a circular array. So here we say array have a face size. After various insertion and deletion operation, the queue array will point to the last array position, giving the impression that the queue is full. But because we remove some item from the front of the queue, we may have a space in the front, but at the back, again, we reach the end of it. So in this case, we are going to slide all of the queue element towards the first array position using what we call the circular array. So the array will look something like this. So we can see that it can reach some stage that 99 can be the front of the queue and 0 will be the rear because we're going around, we're shifting. So this is an example again. We reach X and Y, but because we remove a lot of elements in inserting, deleting, we can see that from 0 to 97, we have empty space. But this, if it's linear, it shows that the queue is full because we reach 99, the last index. So when we use again circular implementation, we can see that we can shift the element. So in this case, we are going to use the next can be 0, 1, 2, then we can insert an item. Then if I insert a new item and the item go to 0, that means the queue array will be 0 and the queue front will be 98. If I set another item again, we get to 1 again. So the list keep going. So that's what we did here. We insert an element Z, and we can see now the queue array and queue front changes. So the queue, since the last element we set Z, queue array will become 0 index, the front is 98. Now if we remove an item, the front becomes 99 and the rear becomes 0. And we'll see how the code is written. But now let's go through the code. So the first code we will go through is the default constructor. The goal of a default constructor is, as we know, a constructor is a special method that anytime we create an object, it will initialize. It will initialize, give us the instant variable and variables values. So what we're trying to say here is that we are creating, when we call this constructor, it's going to create a new object queue. And we specify the size that our queue size should be 100. The queue front is point to 0 because there's nothing, is empty. And also the queue array should be the max queue size minus 1. Here we are dealing with the index. So if the size is 100, then we go from 0 to 99. Then we initialize our count. This variable count is going to keep track of the elements inside the queue. So anytime we insert an element into the queue, we are going to increment the count by 1. Anytime we remove an element from the queue, we are going to decrement the count by 1. So here you can see that we need at least a minimum of 3 instant variables before we create the array object also. We need queue front, a variable to keep track of the element in the front, queue rear, the position, and then the count. These are the 3 major ones. And then the max queue size instant variable is just to indicate the size of the array. So you can see that when we declare the size of the array, the index, instead of writing 100, we wrote max queue size. So this will create again the array to implement the queue. Now we know we are using the T generics. This means anytime we create an object, we can specify the data type. So again, this is our first method, constructor. This is a default constructor. It initializes the queue to an empty state. There's nothing inside the queue. And specify the size to be 100. Now we also have a method called to initialize queue. So as we said earlier, when we use the queue, after some time, we may decide that we want to bring the queue back to its empty state, delete all the item inside and use it again. So in this case, I'm going to call the initialize queue. So initialize queue will make sure that all the elements in the array, in the queue array has been deleted or removed. So we can see that we are using the for loop. We start from the front all the way to the end. But instead of saying I equal to Q front, which is 0, I is less than the Q rear because we go up to 99 or less than 100. Now, instead of saying I equal to I plus 1, we are saying I equal to I plus 1 modulus mass Q size. The modulus mass Q size make it possible for us to have a circular Q. So let's put some value here. Now, if the size is 100, let's assume 100. So if I reach the 87 position, when I increment, I should go to 88. So 87 plus 1 is 88. 88 modulus 100, the answer is still 88. So that will move me to 88 until I reach the mass Q size. So when I reach 99, 99 plus 1 is 100. Remember, 99 is the last element because 0 to 99. So when I reach the last element, automatically from the diagram we saw before, we start all over from 0. So this mathematics will work for us because 99 plus 1 is 100. 100 modulus 100, which is the mass Q size, give me 0. So when we reach the end, we start from 0 all over. So that's why, again, we have the I equal to I plus 1 modulus mass Q size. So that when we reach, now when I reach 98, the modulus operator will not work because 98 plus 1 is 99, which means I'm in the last index because 99 modulus 100, the answer is still 99. So we go through all the elements in the array using a for loop once at a time. Then we initialize all the elements in the array by null, putting it in an empty state. So null for Q front 1, 2, up to the end. Then after that, we initialize our Q front variable also to 0 and the Q rear to the 99 or the mass Q size minus 1. Then the count also to 0. So you can see that in the default constructor, we have the same initialization. The Q front was 0, the Q rear was mass Q size minus 1. The count is 0. The count is 0 means there's nothing in the elements. For initialization Q, assuming that we used this Q before, and we want to delete everything and make it an empty state. So you can see here, we say the mass Q 100, Q front 0, Q rear is mass Q size minus 1. Then the count is 0. So this will put everything in empty state. The same concept here. But here, first of all, we use the for loop to go through all the elements in the array. In this case, the Q array, and assign node to it. The goal is to deleting the possible element inside. The next is to check if the Q is empty and also if it's full. So it's empty Q, very straightforward. As we said earlier, the variable count will keep track of the number of elements inside the Q. So here, to check if a Q is empty, I'm going to check if the count equal to 0. If the count is 0, that means there's nothing inside. Now, if the Q is full, that means the count will reach 100, the mass Q size. So we are checking if count equal to mass Q size. If this is true, we return true so we can see the returning type of the method is Boolean. If it's false, we return false. The same thing applies to the is empty. If the condition here is true, we return true. If it's false, we return false. Now, the method front, as we said earlier, is to check what is in the front, what element in the front of the Q. So if I'm going to check, of course, first of all, if there's nothing in the Q, then there's nothing in the front, nothing in the back. So we don't want to cause an underflow, same as trying to remove an item from empty Q. So here first we call the function is empty to check. If the condition is true, which means the Q is empty, then we are going to throw our Q underflow exception and we come out of the method. Otherwise, if it's not empty, then we return the Q front. If you remember, we said the variable Q front keep track of the element in the front of the Q. So we return list. List is the name of the array. So list, the index is Q front. The same thing applies to the underflow and the back. And the back also we have to check. We want to check what is in the back of the queue. So still we may have the queue underflow problem if there's nothing in the queue. So we call the method is empty queue to check if the queue is empty. If it's empty, then we throw the queue underflow exception. Then we get out of the method. Otherwise, we are going to return the queue where the queue instance tells us the last element in the queue. Now, how do we add an element to a queue? I'll say the algorithm is very straightforward. First, we are going to add an element, a re-implementation. So we are going to check if the queue is full, if there's a space. If there's a space, then we can increment our counter. We assign the value to the queue. And also, when we are assigning the value to the queue, means we have to increment the queue rear, because we're inserting from the rear. The reason why I say we should increment the count variable will keep track of the number of elements in the queue. So anytime we insert an element to the queue, we increment the queue variable. Anytime we remove an element from the queue, we decrement the count variable. So we can see the code here. First, we check if there's a space. It's full queue. If it's true, then we throw our queue overflow exception. Then we get out of the add queue method. Otherwise, what we do, we increment, this is again circular array. So to increment the queue array, is queue array equal to queue array plus 1 modulus max queue size. Again, because it's circular. So we increment the array, we increment the count. The count just keep track of the element in the array. So anytime I want to check how many elements are in the array, all I need is to print the content of count. Then the last step is to assign the queue element to the queue array. So it's 3 steps. Check if there's a space in the queue. This is a re-implementation. If there's a space, then increment the queue array by 1. Increment the counter to keep track of the element in the queue, number of elements in the queue. Then assign the queue element to the array. Now, to remove an item from the queue or delete queue, how do we delete a queue? Remember, we have to remove from the front. So this means we have to increment the front. Before we do that, we don't want underflow. We don't want to delete an item or remove an item from empty queue. So we check if the queue is empty. If it's empty, then we throw the queue underflow exception. If it's not empty, then decrement the counter by 1. Assign null to the queue front, which means we are deleting the element in the queue front. Then we increment the queue front by 1. So those are the queue operations. We saw the code for queue front, queue rear, is full, is empty, both default constructor and full constructor. So queues in the Java API, same as we said about Stack. In Java library files, we have a queue class that we can also use. And we will go through this after we finish with this topic and the linked list that we go through. So for example, using the Java API file for queue, we don't need to worry about the detail of the queue operations, what is insert, deleting. We don't need to write the code. All we need to know is how to use, and also the names of the methods, how to use the methods and names of the queue class. So for example, we have the name called hard. Hard method normally will throw an exception if the element cannot be added. And also we have offer method that returns Boolean indicating whether it's success or failure. We also have a remove method which remove an element from the queue through the front. We also have a pull method. So this is the queue ADT. We have the NQ. NQ means to insert an element into the queue. The Q means to remove an element from the queue. First means we want to know the first element in the queue. It's empty, we want to check the queue is empty. The size will give us how many elements we have in the queue. So implementing queue with an array, as we said earlier, here we have an array size, let's say 10 from 0 to 9. We said that always we insert an item into the queue from the rear and we remove an item from the front. So which means we can see the first, since A is in the 0, that means the first element we insert was A, second was B, C, and D. Now if I want to remove first in, first out, so since first item that was inserted is A, it will be the first element to remove. And we discussed about how do we implement a circular array. So if I want to go to the next index, is array equal to array plus 1, which makes sense. If I'm 8, 9, I'll add 1. If I reach 90, I add 191. But if I reach 99 and I add 1, it will be 100. And the index is from 0 to 99. So we use the circular array plus 1, then modulus Q length. So when I reach 100, 100 modulus 100 will give me what? 0. So the index will start all over from 0 again. Again, thank you for these video lectures. And in these video lectures, I'll cover the queue array implementation. Our first lecture, we covered the stack array implementation. The next thing I will do is to go through the code. I'm going to run an example of a code, and that will be a different video. So again, wish everybody the best and see you in the classroom soon. Thank you. Bye. Also, I have a YouTube channel. If you like, you can subscribe to my channel. At the moment, most of the videos in my channel are calculus and pre-calculus courses, and also basic Java and statistics. I will start making recordings in data structure. So hopefully, please, I'll be glad if you can support my channel by subscribing, also like. Also, if you have any comment about the video, let me know, or you can also let me know in the class how to improve the video and what things you think we should explain more in the video. Thank you very much. Bye. See you.